This is questions 1, 11, 16 and 18 in exercise 1.3 in Project Maths 2. We have to factorize each of the following. So we'll start with question 1 over here. So the first thing we're going to look at for this is, without knowing what type it is, we'll check is there a highest common factor between each of the terms. And whilst there is a highest common factor between the first two terms in this expression, there isn't when you include the third. Also, there isn't enough terms in this to treat it like a factorising by grouping. So what we've got here is we've got a term with an x squared, a term with an x, and a term without any x attached. So what this is a quadratic trinomial. So we're going to factorize it as such. Now the answer in the end is going to be one bracket multiplied by another bracket with two terms in each bracket. But we've got to get to that point first. Our starting point for this is we're going to take our coefficient of x squared, the number in front of x squared, which in this case is 2, and multiply it by the constant, which is the number without a variable attached. So 2 times 3, and we're going to get 6. And then we're going to look for factors of 6 that sum up to 5, which is our number in the middle here. So our factors of 6 are 1 times 6 and 2 times 3. Now, 1 and 6 would work if we were able to take 1 away from 6, but we don't need that right now. We're dealing with positive numbers, but 2 plus 3 will work. So what we're going to do now is we're going to rewrite this expression. So instead of 2x squared plus 5x plus 3, we're going to write 2x squared plus 2x plus 3x plus 3. So all we've done is we've split up this 5x. If we added 2x and 3x together, we'd end up with the term we started with. And the reason we do this is now we've turned it into an expression that we can factorize by using the grouping method. So if we take the first pair together, the highest common factor from them is going to be 2x. And inside our bracket we're going to get x plus 1. And then from the second pairing, our highest common factor is going to be 3. So we're going to get 3 multiplied by x plus 1, like that. And now we can see that there's a common bracket here of x plus 1. So we can write that down by itself. We get x plus 1. And that's going to be multiplied by 2x plus 3, the terms that were outside of the brackets. Now if we were to multiply these brackets back out, we would get our original expression back, and that is a way that you could go about verifying that you've got the correct answer should you need to. But now that we've seen that method done, let's see if we can apply the same reasoning to the next question. So in question 11 we've got 3x squared minus x minus 10. So we'll start off same as before, coefficient of x multiplied by the constant. In this case we get minus 30. And now we're looking for factors of minus 30 that will sum to the coefficient of x, which in this case is minus 1. There's no number written there, but whenever there isn't a number written in front of a constant, we assume there's a 1 there. So we're looking for factors of minus 30 that will sum to minus 1. So the factors of minus 30 are going to be minus 1 times 30, or 1 times minus 30. They're going to be minus 2 times 15, or 2 times minus 15. Or they're going to be minus 3 times 10, or 3 times minus 10. Or they're going to be minus 5 times 6, or 5 times minus 6. Now, the 1 and 30 pairings won't work, the 2 and 15 pairings won't work, and the 3 and 10 pairings won't work. There's too big a difference between them. But our minus 5 and 6 pairings will work. But we need to get to minus 1, so we're going to use minus 6 and plus 5, because minus 6 plus 5 gives us minus 1. So when we rewrite this expression, we now get 3x squared minus 6x plus 5x minus 10. And now we can factorize this by grouping. So from our first pair, the highest common factor is 3x. So we get 3x times x minus 2. And our highest common factor from our second pair is going to be 5. So we get plus 5 times x minus 2. And now we've got a common bracket, so we're going to write that down. We get x minus 2 times 3x plus 5. Like that. And that's our factorized. Now 16 and 18 are same sort of method, but this time around we don't necessarily need to go for the grouping method for this one. So with these ones, because there's no coefficient in front of our x squared this time, we're going to see another way of approaching these. So this time around we can just go straight to our brackets. Our first term in each bracket are going to be factors of x squared. That's just going to be x and x. And our second term in each bracket are going to be factors of 21 that sum to minus 10. So let's write out all of our factors of 21 just so we can see how this goes. So we've got 1 times 21, we've got 3 times 7. Or we've got minus 1 times minus 21, or we have minus 3 times minus 7. And the reason I use those is because you notice that we need to get to minus 10. And whilst 3 plus 7 gives us 10, we need a minus 10 for this. So we're actually going to take minus 3 minus 7 for this. So x minus 3 and x minus 7. And that's it, fully factorized. We can apply the same reasoning over here to question 18. We jump straight to our brackets. And we've got factors of x and x. And now we're looking for factors of minus 12 that sum to minus 4. So let's go through the factors of minus 12. We've got minus 1 times 12, or 1 times minus 12. Minus 2 times 6, or 2 times minus 6. And minus 3 times 4, or 3 times minus 4. And we can see from this that if we're looking to get to minus 4, minus 6 plus 2 works the best. So that's going to be x plus 2 and x minus 6. And that is that.